Let your body become still. Allow the surface beneath you to carry your full weight. There is nothing you need to accomplish right now. Nothing you need to solve. Tonight we move gently, not outward, but inward. Imagine the room around you slowly dissolving into softness. The edges of objects lose their sharpness. The air feels wider. The distance between things seems to stretch. Now imagine that we begin to shrink. Not suddenly, not dramatically, but gradually. We pass beneath the surface of your skin, beyond cells, beyond molecules. And as we descend, something unexpected reveals itself. What once felt solid begins to open into space. Matter is not compact substance. It is structure suspended in vast emptiness. If an atom were expanded to the size of a cathedral, its nucleus would be no larger than a marble at the center, and everything else would be open space. You are made mostly of emptiness. At the heart of each atom lies a nucleus, tightly bound protons and neutrons. Around it, electrons do not orbit like tiny planets in precise circular tracks. They exist instead as probability distributions, regions where they are likely to appear if measured. An electron is not a miniature sphere. It is a pattern, a structured possibility. The discovery of this changed everything. For centuries, the universe was imagined as a clockwork machine, solid pieces moving along predictable paths. But experiments at microscopic scales told a different story. When light shines on certain metals, electrons are ejected only if the light reaches a specific frequency. Energy does not flow smoothly at that scale. It arrives in packets, quanta. Light behaves like particles, and particles behave like waves. This dual nature is not metaphorical. It is measurable. Imagine a single particle approaching two narrow openings. If it were a tiny marble, it would pass through one slit or the other. But when particles are sent one at a time, an interference pattern slowly emerges on a distant screen, a signature of wave behavior. It is as though each particle spreads out, exploring multiple paths simultaneously. And when we measure which path it takes, the wave-like pattern disappears. Observation changes behavior. This is not mystical. It is structural. To measure is to interact. To interact is to alter the system. At the quantum scale, there is no neutral distance between observer and observed. There is also a built-in limit to knowledge. The more precisely we determine a particle's position, the less precisely we can know its momentum. The more tightly we define its motion, the more uncertain its location becomes. This is not technological limitation. It is mathematical necessity. Uncertainty is woven into reality. And without this uncertainty, atoms would not remain stable. Electrons would collapse into nuclei. Matter would not form. The softness of probability creates solidity. To describe this behavior, physics uses wave equations, expressions that do not track sharp trajectories, but evolving probability amplitudes. From these equations arise orbitals, elegant shapes that determine chemical bonding. Every molecule in your body exists because of these quantum shapes. The air you breathe, the water you drink, the neurons firing quietly in your brain, all governed by probability waves. Modern physics then took an even deeper step. Particles are not fundamental objects. They are excitations of fields. A field fills all of space. It exists everywhere. When a field vibrates in a localized way, we observe what we call a particle. An electron is a vibration in the electron field. A photon is a vibration in the electromagnetic field. Space is not empty. It is alive with fields. Even in vacuum, far from stars, far from matter, these fields fluctuate. Tiny disturbances appear and vanish within the allowances of quantum uncertainty. The vacuum hums with restless activity. Nothing is ever truly still. Four fundamental forces guide these fields. Electromagnetism binds atoms and allows light to travel. The strong force binds quarks into protons and neutrons. The weak force enables nuclear transformations in stars. Gravity curves space and governs cosmic structure. Three of these fit within quantum field theory. Gravity remains unresolved. Our map is detailed, but incomplete. And yet, from this probabilistic foundation arises stability. From uncertainty emerges order. From fluctuations emerge stars. This is the quiet architecture beneath everything. As we remain in this smaller scale, allow your breath to move gently and without effort. We have seen that particles are not solid beads, but ripples in fields. That uncertainty is not an error, but a feature. That emptiness is not truly empty. Now let us widen the frame slightly, because these subtle rules do not stay confined to the microscopic world. They shape technology, biology, and even the structure of the cosmos itself. At the heart of modern life lies information. Classical computers store information in bits, units that are either 0 or 1. A switch is on or off. A current flows or it does not. But in the quantum world, information behaves differently. A quantum bit, or qubit, can exist in a superposition of 0 and 1 simultaneously. Not half of each in a vague way, but in a precise mathematical combination. When multiple qubits interact, they can become entangled. Their states are no longer independent. Instead, the full system must be described as a whole. Information becomes relational. This is the foundation of quantum computing. Instead of checking one possibility at a time, certain quantum algorithms use interference to amplify correct answers and suppress incorrect ones. The system does not simply guess randomly. It evolves according to carefully engineered wave patterns. And yet, these states are delicate. Quantum coherence, the alignment of phase relationships, must be preserved. Even small disturbances from the surrounding environment can disrupt this alignment. This process is called decoherence. When decoherence occurs, the quantum system begins to behave classically. The rich superpositions collapse into definite states. Engineers designing quantum processors must isolate them from heat, vibration, and stray electromagnetic fields. Often, they are cooled to temperatures near absolute zero. It is an effort to protect possibility. Another application emerges from a simple principle. Measuring a quantum system disturbs it. In quantum cryptography, two parties exchange photons encoded in specific quantum states. If an eavesdropper attempts to intercept the photons, their measurement inevitably alters the states, revealing the intrusion. Security becomes rooted in physics itself, not in secrecy of algorithms, but in the unavoidable disturbance of measurement. Quantum sensing extends these principles further. Atomic clocks rely on quantum transitions between energy levels in atoms. These transitions occur at extraordinarily stable frequencies. By measuring them precisely, modern clocks achieve astonishing accuracy. Without them, global positioning systems would drift by kilometers within a day. Magnetometers based on quantum effects can detect minute magnetic fields, sensitive enough to map brain activity or reveal hidden mineral deposits underground. The quantum world quietly enhances the precision of our tools. But these principles are not confined to machines. There is growing evidence that biological systems may also make subtle use of quantum effects. In photosynthesis, when a photon strikes a chlorophyll molecule, its energy must travel through a network of molecular structures to reach a reaction center. Experiments suggest that this energy transfer may involve a form of quantum coherence, allowing it to explore multiple pathways simultaneously before settling into the most efficient route. It is not wandering randomly. It is guided by wave-like behavior. Certain migratory birds appear able to sense Earth's magnetic field using specialized proteins in their eyes. The underlying mechanism may involve entangled electron spins sensitive to magnetic orientation. If so, these birds navigate using delicate quantum processes. Life, it seems, may be quietly aligned with the laws of the very small. Now let us lift our gaze outward, far beyond Earth. In the earliest moments after the Big Bang, the universe was unimaginably hot and dense. Quantum fields fluctuated with tiny variations in energy. As the universe expanded rapidly, these microscopic fluctuations were stretched to cosmic scales. They became the seeds of galaxies. The vast web of clusters and voids observed today may trace back to subtle quantum ripples in the early universe. The largest structures we see began as quantum whispers. Yet despite the success of the standard model of particle physics, which describes known particles and three fundamental forces with remarkable precision, mysteries remain. Galaxies rotate as though they contain far more mass than we can see. This unseen mass is called dark matter. Its nature is still unknown. Even more puzzling is dark energy, a phenomenon inferred from the accelerated expansion of the universe. Space itself appears to be stretching faster over time. What drives this acceleration remains uncertain. Our equations describe it, but do not fully explain it. And then there is gravity. General relativity describes gravity as the curvature of spacetime, a smooth geometric framework. Quantum mechanics describes discrete excitations and probabilistic states. When we attempt to combine them directly, inconsistencies appear. Near black holes, or at the earliest moments of cosmic history, both frameworks are required, yet they do not merge cleanly. Physicists have proposed candidates for a unifying theory. String theory suggests that fundamental constituents are not point-like particles, but tiny vibrating strings. Different vibrational modes correspond to different particles. Loop quantum gravity proposes that space itself may be composed of discrete units, a kind of granular fabric. These ideas remain under investigation. The search continues. Notice something quiet here. Despite deep uncertainty, the structure of reality is astonishingly coherent. From subatomic scales to cosmic expanses, mathematical consistency connects phenomena across 20 or more orders of magnitude. The same quantum principles that govern electrons in your body also influence the formation of galaxies. There is continuity across scale. As you rest, let that continuity feel steady. You are not separate from the cosmos. The atoms in your body were forged in stellar cores. The forces holding you together are the same forces shaping distant stars. The fluctuations that seeded galaxies contributed to the conditions that made your existence possible. You are a localized pattern within a vast, evolving field. Stable, yet dynamic. Structured, yet open. Soon we will turn toward the deeper philosophical questions these discoveries raise. What does it mean for reality to be probabilistic? Is randomness fundamental? What role does observation play? But for now, simply allow the scientific landscape to settle. Fields vibrating, forces balancing, information flowing, galaxies forming, all expressions of one underlying framework. And you, breathing quietly, part of that same unfolding structure. Let your breath slow a little more. Now we arrive at a quieter horizon. We have explored atoms, fields, forces, information, stars. We have moved from the smallest measurable scales to the widest cosmic structures. And yet, beneath all of this, lies a question that is less technical and more reflective. What does it mean for reality itself? Quantum mechanics does not only change our equations, it changes our assumptions. In classical physics, objects possess definite properties, whether or not we observe them. A planet has a position. A stone has a velocity. The world unfolds like a precise mechanism. But in quantum theory, systems are described by wave functions, mathematical structures encoding probabilities. Before measurement, a particle may exist in a superposition of possible outcomes. When measured, one outcome becomes actual. Why? This is known as the measurement problem. The core equations of quantum mechanics describe smooth, continuous evolution of probability waves. Yet when observation occurs, the wave function appears to collapse into a definite state. The equations do not clearly specify when or how this collapse happens. Different interpretations attempt to answer. The Copenhagen interpretation suggests that quantum systems do not possess definite properties until measured. The act of measurement brings a specific outcome into reality relative to the measuring apparatus. Probabilities are fundamental. Another perspective, the many worlds interpretation, proposes that the wave function never collapses. Instead, all possible outcomes occur in branching realities. Each measurement splits the universe into consistent branches. No single outcome eliminates the others. They coexist, though we experience only one. There are also hidden variable approaches, proposing deeper, deterministic processes beneath apparent randomness. However, experimental tests, particularly those based on Bell's inequalities, place strong constraints on such theories. If hidden variables exist, they must allow non-local correlations, connections that do not conform to classical separations in space. Each interpretation preserves the mathematical predictions. They differ in what they claim is fundamentally real. This leaves us in a subtle position. Quantum mechanics works extraordinarily well. It predicts experimental outcomes with remarkable precision. It allows us to build transistors, lasers, medical imaging systems. Yet the underlying nature of reality remains open to interpretation. The equations are clear. The meaning is still unfolding. There is also the question of randomness. When a radioactive atom decays at a particular moment, is that moment truly random? Or does some deeper order remain hidden? So far, experimental evidence suggests that quantum events exhibit genuine unpredictability. Not unpredictability due to ignorance, but unpredictability built into the structure of nature. And yet, this randomness is not chaotic. It follows precise probability distributions. There is order within unpredictability. At the edge of current knowledge lies another profound challenge: reconciling quantum mechanics with gravity. General relativity describes gravity as curvature of space-time, smooth and continuous. Quantum theory describes discrete excitations and probabilistic states, near black holes, or in the earliest fractions of a second after the Big Bang. Both descriptions are required, and they do not yet merge seamlessly. Some physicists suggest that space and time themselves may be emergent, arising from deeper quantum relationships. Perhaps geometry is not fundamental. Perhaps information is. Others explore the possibility that space-time is granular at extremely small scales, composed of tiny, discrete units beyond current measurement. These ideas remain speculative, yet carefully investigated. The search continues, quietly, patiently. Notice something peaceful in this. Science does not require final answers to function. It proceeds with partial knowledge, refining models, adjusting theories, exploring possibilities. Understanding is a process, not a destination. As you rest here, consider how this mirrors life itself. You do not possess complete information about your future. Possibilities exist in superposition, paths not yet chosen. Moment by moment, outcomes crystallize, not all at once, but gently. Quantum mechanics suggests that certainty is limited, that connection underlies separation, that probability underlies structure. And perhaps this can feel comforting. The universe is not a rigid machine. It is a dynamic interplay of potential and realization. Your body, too, is a balance of forces. Electromagnetic interactions hold your atoms in stable configurations. Quantum uncertainty prevents collapse. Biochemical processes unfold according to probabilities, guided by molecular structure. You are sustained by countless interactions beyond conscious awareness. You do not need to manage them. They proceed naturally. Imagine again the vast field, extending without edge. Across it, ripples rise and fall. Some ripples stabilize into particles. Particles combine into atoms. Atoms into molecules. Molecules into cells. Cells into living beings capable of reflection. Forms appear. Forms dissolve. The field remains. Even empty space is active. Subtle fluctuations arising and fading within the limits allowed by uncertainty. The cosmos is not silent. It hums softly beneath perception. Let your breathing synchronize with that hum. Inhale, gently rising. Exhale, gently settling. You are not separate from the processes we have described. The atoms in your body were formed in ancient stars. The quantum fluctuations that seeded galaxies influenced the conditions that eventually allowed life. There is continuity across scale, from vacuum fluctuation to star formation to planetary chemistry to awareness. Allow your thoughts to grow lighter now. There is nothing left to analyze, no equation to solve, no interpretation to finalize. Just the quiet recognition that reality is deeper and more spacious than it first appears. Beneath solidity lies openness. Beneath certainty lies probability. Beneath isolation lies connection. And beneath wakefulness lies rest. Imagine your awareness as a wave gradually lowering in amplitude, not disappearing, simply settling, like a particle transitioning to its lowest energy state. Effortless, natural. Gravity holds you gently against the earth. The earth moves in its orbit without strain. Stars fuse hydrogen through quantum tunneling without hesitation. Fields vibrate, forces balance, space expands, all without urgency. You may release effort now. Let the boundaries of the day soften. Let questions fade into quiet background space. Let the mind drift like a distant galaxy, moving slowly through cosmic darkness. You are a pattern within a vast, evolving fabric, stable for this moment, held by laws that have unfolded for billions of years. Nothing is fragile in this instant. Nothing requires your vigilance. The quantum fields continue their silent vibration. The galaxies continue their slow turning. Your breath continues its gentle rhythm, and you can rest. Allow sleep to arrive the way probability becomes actuality, naturally, without force. Let awareness dim. Let thoughts dissolve into spaciousness. Let the quiet hum of existence carry you. Sleep now. The universe continues its calm unfolding, and you are safe within it. Good night.